Okay, hi. I'm just making this video so that you'll have a chance to see a few more complex equations in action. So here we go. So what if we have variables on both sides, kind of like this? 3n plus 7. I'm just going to think in my head and say that's going to be okay, and then I'm going to go this 5n plus 1. I think that'll work. So this equation might be a bit challenging for people to just look at and figure out. So building a model or solving it algebraically might help. So first of all, I'm going to represent my equation here. There's my 3n and 1, 2, 3, 4, 5, 6, and that's 7. That's my positive 7. Over here, I'm going to have 5n. That's 3, 4, 5, and I'm going to have 1. Okay, so I've represented my equation to begin with. Now, I want to end up with n on one side and its value on the other. So looking at my equation and knowing that I'd kind of like to avoid negatives, I'm probably going to end up wanting to keep my n here where 5n is, because it would be easier for me, without avoiding negative, to subtract 3n from 5n. So because of that, I am going to subtract 1 from this side and 1 from this side. Okay? So my intent here is to have at the end my n on this side and the value of n on the left side. Okay? I start that by taking away the 1 on the right side. So 5n plus 1 minus 1, I can take away the 1 here. There it goes. That's me subtracting the 1. And so I'm left with 5n, because 1 minus 1 is 0, and I'm left with 5n. But what I do to the left, I must do to the right, so I'm going to subtract my 1 here. And what am I left with? I'm left with my 3n, and 7 minus 1 is 6. And of course I have 6 ones below here. Okay? Now, I have a numerical term on my left side, and it's represented by my 1's here. So I'm going to let that stay there, and I'm going to want to keep all of my variable terms on this side, which means I need to deal with 3n next. Just take away those marks. So in this case, I'm going to subtract 3n from this side and 3n from this side. Okay? Now if I take a look at my model, what does that look like? 3n going away here, 1, 2, 3, and 3n going away here, 1, 2, 3. Okay? So even though my 3n terms are not together, 3n, they are like terms, so 3n minus 3n makes 0, but I still have my 6 here, which we can see here, right? So on my left side, I have 6, and over here, obviously, I have 2n, which makes sense because I'm subtracting 5n minus 3n, and that's 2n. Okay? Now I don't want to know what 2n is, I want to know what 1n is. So I am going to divide 2n by 2, and I have to do the same thing over here. So what does this look like is I'm taking 2n, I have 2 n's, and I want to put them in 2 separate groups. How many n's are there per group? And the answer, of course, is 1 per group. But I need to separate out my 1's as well. And there we go. Now we can see that the division is going to yield that n is equal to 3. Okay? But we always need to go back to our original equation and check it. So on the left side, we had 3n plus 7. Now let's put a 3 where the n is, and let's use order of operations to solve. 3 times 3 is 9, plus 7 equals 16. And let's go over to the other side, the right side. And we'll have 5n plus 1, 5 times 3, because n is 3 plus 1, that's 15 plus 1 equals 16. My left side equals my right side, so I know that this equation, that n is 3, that I've solved it correctly. Okay? So the rules are exactly the same. What's our objective? Find out what the value of the unknown is. How do we get rid of constant and coefficients? We use the opposite operation with the same value. So if I have a plus 1 that I need to get rid of, I subtract 1. If I have a multiply by 2 I need to get rid of, I divide by 2. And also very important that you must perform the same operations on right side and left side in order to keep it equivalent. I hope this helps. Thank you.